Now we're going to move on to a type of chemical technique which we call gravimetric analysis. If we do a quick Google search, what we're going to look for is the key term here that comes up every single time or in all of the hits. So if we have a look here, we're looking at gravimetric analysis describes a set of methods in analytical chemistry for the quantitative determination of an analyte based on the mass of a solid. Okay, likewise. We have a look at this chem.tamu website here. The quantitative determination of a substance by the precipitation method of gravimetric analysis, and so on and so forth. Again, gravimetric analysis can be determined through the measurement of mass. So think we've got a key idea coming through here. The idea is that we're talking about the measurement of mass. And when we're measuring mass, we're going to obtain some quantitative results. And I think they're our key ideas the whole way through. So if we then have a look at our definition here, what are we doing? What are we going to be doing? And how are we going to be implementing this technique? We're talking about quantitative analysis, which involves the finding of the mass of a part of the sample or various parts of a sample. And what we want to do is we want to relate it back to the sample. So the total mass of the sample, that would be. So that would be relating it back to the total mass of the sample, and often as a percentage. Okay, so if you can envision it as a percentage, what we're looking for is part of the sample, whatever component that we're measuring, over the total mass of the sample. And of course, if we wanted to make that into a percentage, we would then times it by 100. Okay, let's have a look at see how this gets into an example. So here we're being asked to calculate the percentage of carbon in brown coal that had an initial mass of 247.5 grams, and after intense heating to remove all of the water and impurities had a final mass of 203.4 grams. So in this particular instance, they're just looking for the percentage of carbon. So that's what all we're asked to calculate. So if we're talking about calculating this as a percentage, we're looking at the final mass, which is 203 over 0.4 over 247.5, and then we're going to times that by 100. So my percentage of carbon is then equal to, and I'm going to plug that into my calculator. And I end up with a value of 82.18%. And that's as simple as it can. If we move on, this second example asks us to have a look at a 15 gram sample of sterling silver, contains 13.95 grams of silver. The remainder was copper. Calculate the percentage by weight of each metal in the sterling silver. So this time it's asking us to look at both components. So in this particular instance, we're going to calculate the percentage of silver, and then we're going to calculate the percentage of copper in the sample. So once again, I use the mass of the substance given. In this case, it's silver, 13.95, over 15.0, times that by 100, and the value that I get is 93%. So the copper would be a little bit different. So in this instance, I'd go, okay, well, the total mass was 15. if I know 13.95 was the copper, and I plug that in, then I'm left with 1.05 grams, and we're assuming in this particular instance that that whole 1.05 grams is all copper. There are no other metals, as we've been told. So that's an assumption that we're making when we do this calculation. So if we say 1.05 over 15 times that by 100, then the remaining percentage is, then we can see it's pretty obvious from the 93%. If 93% of the sample is silver, then the remaining 7% have to be copper. But it's also good to show how we actually obtained that value using our working. And yours will obviously be much neater than what I've got here. So how does that kind of relate to what we're going to be doing in class? So next lesson, we're going to be competing, or you're going to be competing in your lab groups in the Great Gravimetric Competition. So you're going to apply this idea of using measurements of mass to relate to percentage composition, is what we'll call it. So you'll be given a sample of copper sulfate and sand in order to calculate the percentage composition of each component in the sample. So you'll need a mass for copper sulfate, and you'll need a mass, relative mass for sand as well, in order to relate that back to the total mass of the mixture. These are some questions that I want you to think about and come ready, for next lesson with some answers. Number 1, are these substances soluble or insoluble in water? So we looked previously at separation techniques. We have looked at separation techniques. So hopefully knowing whether or not these two solids are soluble or insoluble in water will allow you to determine what separation technique you'll decide to use in order to get their masses obtained separately. Okay, and to avoid contamination, obviously, because that will affect our results. The other question I want you to ask is, have I used, or will I be using in your instance, accurate measuring techniques? So making sure that we're taking measurements using the correct equipment, that our equipment is calibrated correctly. So when it gives you a value, is it that actual value? Okay, I want you to go and have a look around the term calibration, do a bit of research on that, all that sort of stuff. So if you can come ready to the next lesson with all of those questions at least considered, and have a think about how you might separate the copper sulfate and sand in order to work out the percentage composition, then we can be ready to begin that at the very start of the lesson. Thanks all, and have a great night.